Hey everyone. So, what if an AI could learn new things, grow its knowledge, and just adapt over its entire lifetime without ever forgetting what it learned before? Kind of like how our brains work. Well, today we're diving into a brand new idea that could finally make that a reality for AI.
Okay, so to really get why this is such a game changer, we first have to talk about a massive problem that plagues even the most powerful AI models out there today. It's a memory problem. Just think about how we learn, right? When you learn to play guitar, you don't suddenly forget how to ride a bike. But for a normal AI, it's a totally different story. When you train it on a new task, it can literally overwrite and completely lose its old skills. It's like this one in, one out memory system.
And yeah, there is a name for this, and it sounds just as bad as it is: catastrophic forgetting. This isn't just some tiny bug. It's one of the biggest roadblocks preventing us from creating AI that can truly learn and grow over time, the way a person does.
So, where do you even look for an answer to a problem that big? Well, it turns out the inspiration is right inside our own heads. The human brain is the absolute gold standard for learning. Its ability to constantly adapt and rewire itself, that's neuroplasticity, is exactly what researchers are trying to copy. So, how in the world do you build an AI with a memory that actually sticks around? Let's get into this radical new blueprint that completely rethinks how AI models are put together.
For the longest time, building an AI has been this two-part process. You had one team figuring out the model's structure, its architecture, and then you had another team figuring out the best way to train it, the optimization part. They were treated like two totally separate puzzles to solve. But this new idea just flips that whole thing on its head. The argument is that the model's structure and its training rules aren't separate at all. They're actually two sides of the very same coin, just working on different levels. And this new approach fuses them into one single unified system. It's called nested learning. So this is nested learning. Instead of one giant learning process trying to do everything at once, imagine a whole system of smaller learning loops, all nested inside each other. Each one has its own job, its own flow of information, and they're all being tweaked and improved at the exact same time. Okay, so how does this whole nested idea actually lead to a better, more brain-like memory? Let's dig into how it builds a system that doesn't just store information, but organizes it in a really dynamic way. The secret sauce here is creating something they call a continuum memory system. And it's not a single memory bank. Think of it more like a whole spectrum of memory modules, and each one gets updated at a different speed. Here's how it works. You have these different layers. There's super fast short-term memory for what's happening right now, like the words in this sentence. Then you've got medium and long-term memory that get updated less often. And way down at the bottom, there's foundational knowledge, the core stuff that rarely ever changes, like basic facts about the world. This layering is the whole key to stopping that catastrophic forgetting we talked about.
All right, this all sounds amazing on paper, but the real question is, does it actually work? Well, let's take a look at the model researchers built to put these ideas to the test.
Say hello to hope. This isn't just any old model. It's a special kind of architecture that can actually modify itself using these continuum memory blocks we just saw. This design basically lets it constantly optimize its own memory, which leads to something the researchers call unbounded in-context learning. It just keeps getting better. And the results? They were pretty stunning. When they tested Hope on standard language and reasoning tasks against other top models, it just consistently came out ahead. It had higher accuracy and, as you can see, lower perplexity, which is just a fancy way of saying it was way more confident and less confused by the questions. But where it really shined was on tasks designed specifically to test its long-term memory. On these needle-in-a-haystack tests, where it has to find one tiny piece of info in a huge pile of text, Hope blew the competition out of the water. It proved it could find and recall key details way more effectively. So, the data here is pretty clear. This continuum memory system isn't just a cool theory. It's a much more powerful and efficient way for an AI to manage information and to actually learn over time. So, what does all of this mean for the future of AI? What kind of doors does a breakthrough like this actually open? The really big takeaway here is a fundamental shift in how we think about building AI. By seeing that a model's structure and its training rules are connected, we've basically unlocked a whole new dimension for designing AI. We're not just building bigger models anymore. We're starting to build smarter, more layered ones. And look, this isn't just some small improvement.
The researchers behind it see this as a foundational shift, one that could finally start to close that huge gap between the forgetful AIs we have today and the incredible lifelong learning that happens inside the human brain. And that just leaves us with this fascinating question to think about. An AI that can just keep learning, keep accumulating knowledge forever, that's a pretty profound idea. If we build it, what's the very first thing we should ask it to learn? And never, ever forget.